Hey everyone, thank you so much for joining us today. Before I hand it over to Steve and Jackson to talk about all the great work we've been doing with iFi and HarperDB to solve customer problems, let me take a couple minutes just to ground everyone on what exactly 5G Edge is and why we're doing it. So what is 5G Edge? 5G Edge is combining Verizon's high-performing network with the elasticity of AWS's cloud to drive mission-critical, high-performing, low-latency edge compute on the edge of our radio access network. All this is to deliver real-time enterprise applications to our customers. So what we're doing is we're using our strategic investments, namely Verizon's deep spectrum holdings, our virtualized network services, our ThinkSpace IoT device management capabilities, and our strong security portfolio, coupling it with AWS's compute, storage, and service tools and APIs to enable end-to-end next-generation applications to drive visibility and control all the way from production through consumption in a highly automated fashion. Simply put, we're trying to connect everything faster and more securely to drive differentiated business outcomes for our customers. Now let's talk about the couple different variations of MEC. We have public MEC and private MEC. The way I like to put it is public MEC is about breadth. We're embedding AWS's EC2 compute into the edge of our radio access network, namely the AWS Wavelength product, and delivering the same exact APIs and tools that you use in the cloud to deploy at the edge. So you can set up your VPC in the cloud, develop all your IAM policies, and just push your Kubernetes workloads down to the edge for your latency-sensitive workloads. Just configure your carrier gateway like you would for your internet gateway, and you're good to go. So this is about delivering low-latency, mission-critical applications in a mobile context. So think gaming applications, V2X applications, any applications that you would want to offer on our macro commercial Verizon wireless network. So anything in retail venues where they don't want a lot of equipment in the back of the house. In contrast to private MEC is about going deep. It's about working with our large enterprise customers to solve their business process problems. So think about large factories, warehouses, logistic facilities where they might be in the middle of nowhere, they might not have the best connectivity, or they might have huge facilities, indoor-outdoor coverage where they don't want to have to manage many different Wi-Fi access points and the complexity involved. And they would just want to deliver an easy, simple, private cellular solution, either private LTE or 5G. Couple that with AWS's Outpost offering for an on-site, tightly integrated edge compute offering. Private MEC is also about applications that require secure data governance, where data can't leave the facility, and really offering low-latency, mission-critical applications for the plant. Here, we're talking about a lot of factory applications, whether they be computer vision, robotics control, inventory management solutions for logistics facilities, and the like. All of this, like I said, is built on Verizon's 4G and 5G cellular networks, tightly coupled with AWS's edge compute and our MEC offering. And then what we're putting on top of that is what we call VESA, our Verizon Edge Services and Application Platform. It's our common services framework where we want to deliver simple tool sets to our partners so they can easily scale their edge applications. So whether they want to deploy a Verizon solution, a third-party ISV solution, or their own development solutions, they can do it with the common tool sets. We divide VESA into three main categories: build, deploy, and manage to help our customers. So whether it's creating pre-built PaaS architectures to help customers build their application, which Jackson will cover in a little bit, to talk about how we're working with him to deliver distributed databases out of the box to help developers create solutions, or whether it's any number of Kubernetes building tools that we're dealing in our arsenal, it's all in our Build VESA framework. Then we have deploy. Deploy is our set of APIs and tools that help customers deploy their applications to the edge, namely our Edge Discovery Service API, which you simply call our API, and it can tell you the right MEC location for that moment based on the RAN conditions of our macro network. And then last but not least is manage. That's where we're doing an API mashup service where we combine our ThinkSpace device diagnostics, our network diagnostics with the CloudWatch diagnostics and the applications into a single dashboard so we can expose to customers the metrics that they need to manage their applications. And in doing VESA, we're looking at 4 main problems for customers, namely security, interoperability, complexity, and performance. So let's start with security. We've been working with AWS for the past year or so to create predefined secure templates. So based on your Outpost organizational unit in our Active Directory, we can give out secure access to a number of different tenants. So whether you're a third-party ISV that needs to access the Outpost, or whether you're a system integrator, or you need to give Verizon access, AWS access, or your own applications to your contractors and employees, you can securely partition the Outpost via the policies and give people so they can spin up and spin down their Kubernetes workloads and not affect the underlying Outpost core. In addition to that, you'll also hear at the conference, we're working with HashiCorp and developing predefined Terraform scripts, either with the base Terraform or through their console package to deliver a hardened delivery infrastructure where you can ingest your Kubernetes workloads and deploy it at the edge. And then all of this is tightly coupled with our strong security portfolio and our native 5G cellular security. Then moving on to interoperability. Like I said, not only is it difficult to design a distributed application, and that's where we have our end-to-end design and implementation and consulting services, but we're also creating, as I mentioned before, a number of pre-built reference architectures for customers to easily build edge applications. So we're creating this catalog of pre-integrated edge solutions and then exposing our network APIs to say what exactly are the RAN conditions, how much device congestions you have, so you can do network-aware-based orchestration to ensure that your edge application is performing as it needs to. Then we're creating the common tool sets so you can deploy your application across any edge. So whether it be on-site via Outpost or in our public MEC distributed with Wavelength or in the cloud, you can use the same exact APIs and tools across that whole hybrid edge environment. And then last but not least, like I talked about, it's all about performance. It's creating those API mashups in our developer portal where you can call one API, get the best performance information across the board, and you can view it either in our dashboard or in an API fashion. Moving up the stack, once we move from the platform, we're offering a number of pre-built solutions to our customers to solve their problems. 2 of the main verticals we're looking at are venues and retail, and additionally manufacturing, logistics, kind of transportation hubs. For all of these verticals, we're looking at it from an end-to-end standpoint, from the time that a fan enters the venue to why they're there to when they leave. So if you look at our portfolio, it starts with our accelerated physical access. Think about it, if you're a VIP at an area, you might need to get your ticket checked 3 or 4 times. You don't want to have to go fumbling around through your pocket or bringing out your smartphone to do the check. How great would it be to use computer vision and facial recognition to secure your identity, tie it to your ticket, so you can just walk right into the entrance gate. You can go to the VIP elevator shaft, and then you can go to your VIP lounge, all just by walking through. That not only increases the fan experience, but it also decreases the operational load of people having to check tickets multiple times at multiple locations. Then once you're in the stadium, we leverage our crowd analytics offering to provide real-time heat maps for our customers. So whether it's finding out what is the right restroom to go to, what's the right retail or concession store to get your food, you know where to go at the right time. Likewise, for back-of-the-house employees, for the enterprises running the venues, we can provide real-time heat maps to them so they can see whether there's crowds gathering and it could be a security incident or they're not doing proper social distancing for COVID. They can use our real-time heat maps and leverage our crowd analytics offering. Next up is our cashierless checkout. I promised Steve I wouldn't steal his thunder and go, so I'll let him go into that. But this is all, again, it's about providing that frictionless retail experience where people can just come in, pick up what they need, and then get back to their seats. Again, increasing satisfaction, increasing the amount of things people buy, and reducing the amount of staff needed to staff the stores. Then last but not least on this slide is why they're in the venue is creating an immersive fan experience. So again, taking the stuff that we're working on with Jackson and HarperDB to be able to mash up a ton of different immersive 360 content into a singular fan experience application. So taking all those different API calls, combining them together in real time to offer an immersive application while fans can view at the stadium themselves. So that's kind of what we're doing in the venues. Then kind of moving on, we apply those same principles to manufacturing and logistics facilities. So we can take our same accelerated access solution and allow people to manage their contractors and employees going in and out of ports of calls to make sure they have the right access at the right time into the right area of the facility. Then once in the facility, we're using a ton of different computer vision software to do real-time quality assurance analytics, whether it be for their production lines, to say for product defect detection, or for automating the pick and pack process in warehouses to make sure everything for forward and reverse logistics is packed properly, done, and then pushed out to automate the business processes. Next up is robotics automation. We're using that same computer vision, the same cameras in the factories to be able to do dynamic route design for the robots in the factory. So you no longer have to worry about architecting for 6 to 9 months on where different floor sensors are going to be for the robot or setting up a singular function that robot can do. Now you can take the training wheels off, use the video across the board, and put the security functions on the robot, but use 5G, low latency, high-performing networks to do the real-time dynamic route design for the robots in the factory. Then last but not least, our industrial analytic and inventory management solutions, where we can take real-time feeds from all the sensors in the factory or the warehouse and combine them together to provide insights, whether it be for predictive maintenance or for tracking material as it goes through the factory all the way from production to consumption, as I said before. So these are just some of the solutions that we're offering. Now I want to introduce you guys to Steve Carlin, who's the CEO of iFi, to really deep dive into how we're applying this in the retail space to create the next generation retail store.
Thanks, Matt. So again, my name's Steve Carlin. I was hoping to kind of connect the dots between what Matt was just talking about and an actual use case, sort of from the business standpoint. First, let me ground you all in a few tidbits about the retail world. This is not going to come as a shock to anybody here, but the reality is brick and mortar retail really hasn't changed much in several decades. In fact, if I were to take the typical grocery store that you and I shop in, the center store, the place where we walk up and down the aisles, literally hasn't changed in probably 7 decades. Sure, there's the odd inventory scanner, maybe the odd robot going up and down the aisle, or maybe the tags have been digitized, but for the most part, not much has changed. The only thing that's really changed in those stores is the exterior, the perimeter. We have checkout, self-checkout, we've got regular checkout, but otherwise, not much really has changed. But consumer and shopper sentiment definitely has. We want things now, and we want there not to be any friction. And the numbers up on the screen bear that sentiment out. And so what iFi has been trying to do since 2016 is to address some of those shopper issues. And so let me tell you just a little bit about us. We're based in San Francisco. We have about 100 plus stores deployed around the world. We're one of the largest players in the space that doesn't put on a conference called AWS. And we're very proud to be sort of leading the charge here. We play across 4 different continents. We have several different very friendly retailers and global investors, and then some really strong partners, and we're happy to say that Verizon is one of those. And so in the spirit of setting the table and understanding the retail problems, I want to give you this fun fact. The #1 purchaser of Old Spice high-endurance deodorant is a woman aged 35 to 54. She's obviously buying something for her family or for a loved one or somebody that she cares about. But she's obviously not the one using that product, right? She's not the consumer. She is the shopper. So if you know that and you're Procter & Gamble, what do you do differently at the shelf? How do you speak to her? What do you do in what we used to call the first moment of truth? Now, that's not the point of this conversation. It's just that notion of understanding the difference and understanding the shopper's journey is what we're here to address. And so what my dad used to call the hassle factors, right? The hassle of going shopping, the hassle of trying to find a place to park, the hassle of dealing with all the people in the store and picking everything out, and then finally getting to checkout, and then the hassle of having to wait in the line. Boy, that's a lot of friction. And so what this solution does with our partnership with the MEC platform is to really start to address that shopper need. And so obviously there's a lot of benefit to a shopper. Hey, I don't have to stand in a checkout line. But there's also a lot of benefit to the retailer. And that's in the form of operational efficiency and labor optimization. So operational efficiency, certainly there's a lot of data that you can gather, and we'll talk a little bit about that in a moment. But more particularly, there's the opportunity to really address the space. If you know anything about retail, you know that dollars per square foot is one of their key metrics. And the only way you can do that is by either getting more items in the basket or getting more throughput. So if you have checkout lanes in that grocery store we were talking about earlier, you can imagine that that's probably the least productive space they have in the store. Sure, they've got bubble gum and stuff like that up there, and that's high margin stuff, but the rest of it is a cost center, flat out. So if you could get rid of that, and you could either make your store slightly smaller, or you could repurpose that space to maybe merchandise other items and to expand the basket, right? To increase the number of opportunities to sell something, boy, that looks like a big help, especially in a retail world where you're operating on 2 to 4% margin. Labor optimization, obviously, if you don't have cashiers, cashier check lanes, you don't have cashiers. That's a pretty obvious benefit. But you can also, spend that labor elsewhere. You can start to focus on the shopper's needs, right? Higher value tasks can start to be leveraged there. So what is iFi doing? Well, we have kind of 4 main components, but the main thing for you to understand is that we track people and objects through space. It's rather simple in that sense. Obviously, we're a computer vision company, but our platform actually has 4 big components, obviously one of which is computer vision, but entry systems, data processing, of course we're at AWS, had to bring that up, and operating systems, meaning how the store personnel use the platform to help operate the store. So to start with computer vision, well, as I said, we're a computer vision company. That's what we do. We're actually a SaaS platform, not a hardware company. But the benefit of our focus on computer vision is that all you need to work with our platform are the cameras you see in the picture. And frankly, those are off-the-shelf cameras. There's nothing particularly special about those cameras. It's just that all you need to do for our solution is put that in with a little bit of wiring. You don't need to electrify the store shelves. You don't need to put in sensors, weight sensors. And all of that's to the advantage of the retailer and their costs. But more particularly, it gives them flexibility. They don't have to change anything about that store to leverage this platform. And it works whether it's 200 square feet or 7,000 square feet, like a store we have with Aldi in London. The other benefit is we can operate with pretty much any item that they have in the store. The problem with the weight sensors is it doesn't work so well for bananas, and it doesn't work so well for rotisserie chicken or hot coffee. But our system doesn't really worry about any of that. We can ingest pretty much anything they've got. And the final key piece is our system doesn't require any sort of biometrics. You don't have to scan your palm to walk in. And frankly, I don't care if it's Matt or Jackson or Steve walking in. I just care that it's a warm body associated with a payment method. And so for the GDPR regulations, for a lot of the retailers' concern about privacy, it becomes a bit of a non-issue in that sense. I mentioned data processing. We're pretty happy that our system doesn't have a strong GPU requirement. Our up and down speeds range from, say, 25 megabits all the way up to, at our biggest stores, maybe 50. But that's about a quarter or a half of what our competition have. And that, again, has to do with the fact that we're camera only. But as I say, it's scalable. It doesn't really matter what size the store is. Our GPU utilization is actually quite strong. And when you add the MEC solution that Matt was talking about, now you don't even have the hardware requirement in the back end. And allows that space utilization we talked about. The entry system is probably the biggest friction point in this whole thing. And honestly, we built it so we can be as flexible for our clients as possible. We don't really care if you want to use your own retailer app, though I wouldn't recommend it. That's not generally a good way to get people to do stuff. Or a credit card, or both. It doesn't matter from an aesthetic standpoint if you want to use gates or if you want to use a turnstile. And then payment methods. Obviously, we need to pre-authenticate a credit card, but we don't really care which fintech company you use, whether it's branded or if you want to use our white label, that's fine too. The point is just to make it as easy as possible for our customers to leverage this technology. And then finally, an operating system. This really only works if the store personnel can come in and be efficient. And so we built out a mobile application that allows the store operator to come in and affect the shelves. And what do I mean by that? They can change products if need be. They can change prices. They can move products, all at the touch of the button. All they have to do is, once they've completed that, let the system know what they've done through their handheld device. And it all goes back to the store management portal, which allows for trend reporting and analytics like we've talked about. So all of that is pretty phenomenal. Let's see, I think that's, all right. So I've had several case studies with Verizon. I'm going to have Matt come back up and tell you, because we Rochambeaued and he was very excited to talk about these two case studies. So, but the long and the short of it is, the combined technology together adds an entirely new opportunity for our retail partners in a way that allows them to drive not only their top line, but their bottom line to a large extent, basically in a way that they couldn't do otherwise.
Thank you, Steve. So yeah, as Steve said, I paid him off so I could talk about the great metrics associated with this. So I love talking the case study with the Detroit Lions at Ford Field. As you can see for this slide, the thing that I love the best about it, the pre-solution versus our post-solution, attendance was down between the two of them. Because of COVID and other factors, you can see attendance was down 15%. The average item price was down 25%, though I'm sure with inflation that's gone way back up since then. But the average price was down. And then you look at the below metrics. Even though attendance was down and price per item was down, the revenue still went up 140%. And what was that because? Because people put more items in their baskets. They were able to do more transactions in the same amount of time to get more people into the store faster, so they bought more things and were happy. So it was a great technology to say how can introducing frictionless retail, what it means in real terms. The next case study was with Monster Jam, with the different Live Nation events. So again, you're looking at pre and post. So here, again, attendance was pretty flat across the board. Item prices went up, inflation started to kick in, but store revenue went up way more, 166%. And again, you see people, they put more things in their basket, they did more transactions, more people, more transactions, more things in the basket per transaction, and less time, less staff supporting it. So all that doing to make people happier with less costs to the business and more revenue coming in. So that being said, that's all the great work we were doing at stadiums around cashierless checkout and frictionless retail. Now let me hand it over to Jackson, who's the head of product at HarperDB, to say how we're using distributed databases to create an immersive fan experience app for the golf.
Thank you. So we'll talk about distributed databases just to lay the groundwork here. Distributed database is a database that exists in more than one place. Historically, we have had monolithic data stores like in a data center, and it's very difficult to distribute the full functionality of a database across multiple locations, let alone across the planet. So you'll end up having one central database that handles all your writes, and then you can have read replicas out because lots of people were consuming data. But the more we move to the edge, and the more applications are demanding extremely low latency, the more they need to write at the edge too, because the alternative is massive amounts of latency, right? You've got APIs sitting out there, but you're still making a huge round trip back to your monolithic data store to write data, and then to distribute that back out to the edge where it's going to be used again. So they're not designed ultimately to, or they most of them are not designed, to scale horizontally, where you can have active, and 1,000 nodes around the planet delivering 5 millisecond latency, because you could even put one in your network closet down the hall. They're not technically designed to do any of that. So it's a hard problem to solve, and that's the challenge we have taken at HarperDB. So when you begin to look at the edge and 5G and the cloud and how we are collecting data versus how we are using it and processing it, we've already moved lots of stuff out to the edge, right? We have CDNs. They moved all your assets, all your static assets out to the edge. And then we had Lambdas, like all of those serverless functions that can put your application logic out at the edge. But what we didn't move to the edge was the data, at least not the ability to write and interact with data in a meaningful and intelligent way. So we at HarperDB built a system that could do that, and we built it on top of AWS Wavelength for the case study I'll share with you in just a few minutes. And ultimately, it's more than just reading data, but it's also application logic. It's also TensorFlow and machine learning and artificial intelligence and all the other things that make applications great that rely ultimately on data. So that's why distributed databases are important. But obviously, the idea that you could be writing to individual nodes on opposite sides of the planet, there are certain limitations that come with that, right? We can't do financial transactions, because somebody could, at the exact same nanosecond on opposite sides of the planet, try to take the same dollar out of the same account. And then somebody's out the dollar, and it's probably going to be me. So we don't do that. But there are, for the other 95% of use cases, we are a perfect paradigm for a distributed data store. And ultimately, the closer we can get to the customer, the lower the latency is, and the more we can horizontally scale, as opposed to massively vertically scaling a huge monolithic data store. The horizontal cost model is linear, right? If you try to go from 16 to 32 gigs of RAM, I guarantee you it's more than twice as expensive. Ultimately, it's an exponential cost model when you try to vertically scale. So to give you a little bit of background on HarperDB, and these are all the bullet points that marketing puts in here for me, but ultimately, we were built from the ground up to solve all the problems that we, as developers, always encountered. One was we wanted to be extremely performant, and we didn't want to have to set up all the other tasks from our transactional database into our analytics platform. So we wanted to be able to read and write data at the same time at a high rate, and so we focused primarily on speed, performance, and simplicity. We're built on top of a lightning-fast key-value store, so underpinning all of it is a low-level, just key-value store traditionally that allows us to create automatically indexed data fields, but function like a document store with the convenience of something like a MongoDB. We have integrated HTTP interfaces. We realize that we've often set up applications where we forget to open the connection, or we saturate our connection because we forgot to close it, or we closed it prematurely. And we realize that everybody's already making HTTP calls, so we should just use that as our primary interface. And so we built an HTTP server into it. And then we realized that we wanted to replicate data between all of our nodes. And the most efficient way to do that was not hub and spoke. The most efficient way to do that was through a peer-to-peer or mesh internode replication, including pub-sub, because a lot of times data in a distributed system doesn't need to be everywhere. So it doesn't necessarily need to be a full replica of your database. So you might have raw sensor data pumping into an edge node, but what you're really doing is you have an application that's creating aggregates and maybe pushing that up to the cloud. So we wanted to be as flexible as possible because we, at HarperDB, we are mostly all reformed or partially reformed developers. So we've seen all of the use cases, and we wanted to address all of the pain points we'd had. To that end, we also added what we call custom functions, which is a second API server built into HarperDB that allows you to define application logic and your own API endpoints. The difference between that custom function server and, say, a separate API server is that there's no latency between those two because you have direct access to HarperDB's data model. So you eliminate the latency of having a separate database server and API server. It becomes very simple to package that custom function project up and distribute it across 1,000 nodes as part of your CI/CD pipeline. It's easy to architect. I mentioned like we are schemaless like a MongoDB. We are a document store. But we also index every top-level attribute by default. These are certainly product features, but it's important in a distributed data store and edge compute because a lot of times we don't know what we need to know, and we certainly don't know what we're going to query down the line, especially when you're talking about IoT, where we're collecting perhaps billions of data points, and we're not exactly sure what analytics or what machine learning is going to find important. So we wanted to index everything by default. And then I mentioned easy to scale, linear capacity to cost ratio, the idea that horizontal scaling is going to ultimately present you a better value proposition over time. So moving data closer to your customers delivers both lower latency, and if you have a horizontal cost model, horizontal scaling cost model, ultimately you will lower costs for your customers as well. So I've talked a lot about like how fast life can be when you're living on the edge, especially when you're on the wavelength servers. And now, so I want to apply all of that massive amount of speed to literally the slowest sport in the world, golf. And that's what we did. So we worked with the golf experience presented by Verizon. It is their Verizon branded product. They have these 4G LTE and 5G LTE rugged tablets with speakers. If you've ever golfed and you're really good, you probably never look at that thing other than to realize how far you are. But if you're not good, you can be distracted by lots of things, right? So there's not only just the golf course itself, but there's streaming radio and ordering my food and looking at sports scores and keeping track of all of that data in one cool interface so you're not constantly on your phone and being distracted from what I'm sure is an outstanding round of golf. But for most of us, it is not an outstanding round of golf, and a little distraction is more than welcome. They have third-party content integration, and ultimately the revenue model for this is based on ads. So there are ads that appear for certainly things in the clubhouse, but then other traditional, more ad-serving products. And ultimately, our vision for this was that we could have some sort of interaction, some sort of intelligent interaction like machine learning that would help you golf better. Like I've noticed that you, like a Clippy that pops up and says, I notice you're in the sand again. Perhaps you need to be better at golf. Perhaps lessons are something that I could market to you based on your behavior. That's very, very hard to do if you're adding functionality on a little tablet that hasn't been swapped out or needs a life of an average of 5 years, because I can't add that much functionality. I can't add that much processing onto that device itself, so I need to do it in an intelligent way. And if you look at what they were actually doing, they have 33,000 golf carts around the United States. Each of those golf carts, each of those units was making 60+ third-party API calls. So a call from each device calling out to get weather, to get sports scores, to get ads, to get all of these things. And the latency on some of these golf carts was massive. And ultimately, you were seeing session stacking, and you were seeing an incredibly slow user experience. And so they came to us and asked us, how can we help? The first thing we did was took a look at it, and we realized that a lot of the stuff that was written, those API calls, you couldn't swap out, right? It's hard-coded. And in order to do that, you would have to roll out new code to every single one of these devices. And that takes a fairly decent amount of time with testing. And rather than just getting weather from openweathermap.org with your API key hard-coded into the device, oh my God, we could send you to /getWeather, and ultimately you could swap out the weather service behind the scenes. So we moved a lot of that application logic out of these devices, and we moved it up to the wavelength servers. And we put those 19 wavelength servers all around the country, and we had some substantial advantages as we did that. Ultimately, for things like weather and sports scores, we created a distributed API cache. So we were storing the results that came back from, say, OpenWeatherMap or from Yahoo's Sports RSS. But then the second thing we were doing, we were taking a lot of that content and we were paring it down. So before we would return it to you, we would maybe take that massive XML document that comes from Yahoo Sports, we would turn that into JSON, and we would eliminate all of the cruft that wasn't necessary so that you just want to display literally the 2 team names and the score and how much time was left. That document was 10% of the original size of that document. So we dramatically lowered the amount of data we were shipping back and forth. And ultimately, we would persist that reply in one node, because sports scores don't change nationally, but we would then replicate that return across the cluster of 19 instances. And then when the second golf cart called for the sports scores, rather than that origin API call, which could sometimes take a second, 2 seconds, up to 5 seconds for some of those API endpoints, you would get back a cache response in as little as 5 milliseconds, but on average about 20 milliseconds. So ultimately, it was an extremely beneficial move. And because we were moving less data down, and because it was exactly the data that the UI needed, you literally took that and put that JSON into the UI and displayed exactly what was there, rather than shaping and processing. And you can imagine, much like a retail store, where you need very, very fast processing, because their only hardware requirement, right, is a camera and moving video back and forth, because you can do the processing on 5G. This opened up machine learning. This opened up a tremendous number of options in terms of user behavior, user location, and what ads we were going to serve them, including a TensorFlow.js inventory management system that we created for ads that were hosted by the golf course itself, or for vendors and sponsors that were perhaps outside the traditional ad network. So the results, as I mentioned a little bit, 250 times faster, greater stability, and reduced code rolls. Again, we moved so much of that logic out that get sports scores /NFL as an endpoint simply returns those sports scores. And if I wanted to move to a different vendor, I can do that. Next up, we're going to probably swap out the UI, which is a native application, for a hosted loaded UI. So we can swap out literally everything for a hosted edge-served application tier. Ultimately, the reduced device processing extends the life of those hardware platforms, so they're not swapping out 33,000 iPads. And again, I mentioned the low latency of that round trip to the server enables all of those forward-looking functions and functionality that we desperately want to do, like machine learning, caddy, intelligent, like recommendations, you should get better clubs, or perhaps take a lesson. So HarperDB running on Verizon's 5G Edge. We have a self-serve platform as a service model. We're built in all 19 regions, and it's super easy to go online and spin them up, and that's exactly what we did for the golf experience. We were one of the first applications that you could simply go in and spin up an application on Wavelength. And we built it in the same way we sort of built our database. It should be easy to be out there on the edge. It should be simple to gain all of the efficiencies that we promise you when we spend billions of dollars building out the entire Wavelength platform. It shouldn't be that hard. So my personal motto is it should just work. And ultimately, that's what we are trying to do. And if you look at this architecture diagram, one of the benefits of this is that while you have the Wavelength instances, and they all talk to each other, you can also have traditional internet, because again, Wavelength instances are only available if you're on the 5G network, if you're on Verizon's network. However, sometimes the golf carts would move out of that, and they would be in the barn under the golf course, right? Under the clubhouse. And they would be on Wi-Fi. That's where they would get their product downloads every night. And ultimately, we can have public internet servers because of our pub sub that can have bidirectional data replication between the public internet and Wavelength instances. So we can move that not only between those Wavelength instances, but between other Wavelength zones around the world. So we can set up a global effective relay between all of the providers of Wavelength services and deliver those extremely fast 5 millisecond response times for applications worldwide. And that is HarperDB in a nutshell. So to recap at this point, I don't think it's going to be me. Let's wrap up. Thank you.
No, thank you so much, Jackson, and thank you, Steve, for talking about a couple deep dive use cases and what we're doing both in the cashierless checkout, frictionless retail experience, as well as what we're doing to combine a distributed database to deliver an immersive fan experience. So again, just to recap on all the great work that we've been doing over the last couple of years with 5G Edge. As Jackson mentioned, we've worked with AWS to deploy 19 wavelength zones across the United States. As you can see by the map, we're pretty much everywhere. We got good coverage, so you can have low latency, high performing edge compute anywhere you need it in the US. We've grown our private network portfolio, so we have very low cost, unlicensed spectrum, CBRS-based product offerings with Solona, growing all the way up to our fully managed licensed spectrum offerings where you can create both a private network with private SIMs as well as combine that with Verizon wireless macro SIMs all into a cohesive network so you can have both macro network and private network in the same facility and handle those handoffs. So we have a robust private network portfolio that you can use for your on-site locations. And then we've been doing a lot of great work with system integrators. As we said, there's a lot of different companies, a lot of different systems involved when we're building these edge applications. And our goal is to make it as simple as possible. And we know that the system integrators are working very closely with a lot of the enterprises. They're integrating your applications with the enterprise customers. So again, we're trying to reduce the friction as much as possible in the edge experience by working with the leading system integrators across all our key verticals. We talked a lot about the different solutions we're all offering customers. Let me take a couple minutes just to wrap up before we get to Q&A about some of those other customer wins. Jackson and Steve talked about the great work we're doing in venue and sports. We have a ton of different teams across the NFL, NBA, and NHL we're working with. You all might have heard a lot in the press about our work with the Associated British Ports. This is a big, seaport, port and logistics facility in the UK. They had something like 70 plus different Wi-Fi access points, managing different security groups across those access points, managing the vast outdoor coverage. It was consuming a lot of their time, a lot of their resources. So we worked with them to roll in a simple private cellular network where we can manage that all seamlessly for them so that they can move from the network and we can start working with them on what edge use cases we could do. So evaluate their business processes and say what are the target use cases, whether they be intelligent video for security applications in the port or different inventory management tracking use cases, kind of flush those out with the port and kind of deliver that business differentiated business value to them. We're taking those same lessons learned that we did with the Associated British Port and applying it to the Virginia International Terminal and a lot of other logistic ports around the world. In the financial space, we're doing a lot of work with BlackRock, MasterCard to, again, get them started with private network to say, now if you deploy a simple private network, a high-performing, low-latency private network in your facility, what use cases can that unlock? Whether it be high-frequency trading or anything else, kind of working with them on that stepwise function to say, get the private network in place, start talking to them about use cases, and then scale commercially across the board. In healthcare, we have Bayer mentioned here. That's another international opportunity. We have other ones that I couldn't put on the slide, but working with some leading US healthcare providers and hospitals to say, how can you aggregate all the different devices across the hospital into a seamless gateway to process it for edge application? There's so much technology in hospital rooms, kind of eliminate some of that technology, eliminate some of the things, and have the doctor focus on you, focus on the patient. So that the technology just works, it can evolve in a low latency fashion. And then last but not least on this slide, Moog. That's a good one. It's a solar powered company out in kind of more rural area. So again, working with them to install a private network, kind of take the networking off the case so we can then talk to them about their use cases and automate their business processes.
That's all our time. Thank you guys
Finding the next hero 5G Edge use
here.
case. That's what I got.
Thank you.
Thank you all so much.